to Vansig Maths. We look at Newton-Raphson method. Remember to subscribe. The question is, given the function x cubed plus 2x minus 1 is equal to 0, show that the root of the equation lies between x is equals to 0, x is equals to 1. Use Newton-Raphson method to determine the root correct to 4 decimal places. So we first of all show that the root lies between 0 and 1. So you have your function f of x. We have f of x as x cubed plus 2x minus 1 equals to 0. So we can find f of 0. So your f of 0 will be 0 cubed plus 2 times 0, then minus 1. So your answer will be negative 1. Then f of 1, now when x is 1, you'll have 1 cubed plus 2 times 1 minus 1. This will be 3 minus 1. We have 2. So at this instance, it is your f of x is less than 0 when x is 0. Then we have your f of x being greater than 0 when x is 1. So by intermediate value theorem, then it means this one, the sign changes. At this point, it is where the sign changes. So it means the root lies between 0 and 1. So from there, now we want to do the Newton-Raphson method. So we are going to choose our x0. So we can choose a value which lies between 0 and 1. Then we start approximating. So you can take 0.3, lies between 0 and 1. So we have x0 to be 0.3. So we have our function f of x is x cubed plus 2x minus 1. Then we need to find f prime of x. This one will be 3x squared, so we differentiate plus 2. So for Newton-Raphson, we have xn plus 1 equals to xn and minus f of xn, then f of f prime of xn. So we already have our xo, so I need to find x1. So it means your x1 based on the equation, now it will be x0 minus f of x0 over f prime of x0. So x0 is 0.3, and you have minus, so f prime of x0, you substitute x0 in the equation for f of x, which is 0.3. then we have cubed plus 2 times 0.3 minus 1, then divide by f prime of x0. So you substitute x0 in the differentiated f prime of x. So we have 3 into 0.3 squared plus 2. So when you calculate in the calculator, you are going to get 0.4643. So we go to x2. So if you substitute in the equation, this one to be x2, it means n is 1, so x2, it will be x1 minus f of x1 over f prime of x1. So repeat the same procedure. x1 we've gotten as 0.4643 minus, so f of x1, you replace x1 in the equation of f of x. So x1 was 0.4, yeah, 0.4643 cubed plus 2 times 0.4643 minus 1, then divide by 3 times 0.4643 squared plus 2. So you're going to get x2. If you press in the calculator and do the everything, you will get 0.4534. Then from there again we go to x3. Now from the formula, x3 doesn't need, if this one is x3 then it means n is 2, so you'll have x2 minus f of x2 over f prime of x2. So your x2 0.4534 and minus, so replace everything in f of x with x2, 0.4534 cubed plus 2, 0.4534 minus 1 over 3 times 0.4534 minus 2. If you do the calculation, you'll find that your x3 now will be 0.4534. So you'll come to realize that reaching at this point is no much significant difference between the two. So approximately your root, it will be 0.4534.